Welcome back to my chemistry lessons. Today I'm going to discuss some of the important organic reactions. So we're just going to see what is Wurtz reaction. Wurtz reaction is an organic reaction in which we can convert alkyl halide when treated with the metallic sodium and ether into higher alkanes. And this reaction is known as a Wurtz reaction. So another thing I have to discuss here is how we can convert an alkane into alkene. For example, propane. How we can convert propane into propene. So these two reactions we are going to see here today. So let's see. Reaction is a preparation of higher alkanes from alkyl halide when an alkyl halide is treated with metallic sodium in ether solution. So here ethyl bromide, because it contains two carbon atoms, we call it as a ethyl bromide. There is a bromine attached to an ethyl group, so ethyl bromide, treated with the metallic sodium in ether solution. So the reaction is taking place like that. The sodium combine with or react with the bromine of two ethyl molecule and forms NaBr, 2 times NaBr. So we get 2 NaBr, and the remaining portions, there is a CS3CH2 group. This group is called ethyl group, and that group is combined with the other ethyl group and result in the formation of CS3, CH2, CH2, CS3. So it contains 1, 2, 3, 4 carbon atoms. So the hydrocarbon with the 4 carbon atoms and all single bonds is called normal butane. Normal butane. So we start from hydrocarbon with the 2 carbon atoms and result in the formation of a 4 carbon atoms. So this is called Wurtz reaction. So here is another example for Wurtz reaction, that is 2-bromopropane, because it contains 1, 2, 3 carbon atoms and all the single bonds, so it is a alkane, but there is a bromo group at the second position, so it is called as 2-bromopropane. Combine with the or react with the Wurtz reagent, that's a metallic sodium in either solution, forms a branched hydrocarbon. So the reaction is taking place, as I explained earlier, the halogen combined with the sodium, so we'll get a 1 sodium bromide. Similarly, the sodium combined with another halogen, so we will be having 2 sodium bromide. So the resulting group, and after bromine leaves, there is a group left here, and there is another group that's called propyl group. Here is a propyl group because 1, 2, 3 carbon atoms containing alkyl group is a propyl group. So these two alkyl groups combine together and forms a branched hydrocarbon. In this case, 1, 2, 3, 4. So the parent compound is a butane, because because it contains 4 carbon atoms. So there are 2 branches at position 2 and 3. So we have to specify that 2, 3. There are 2 methyl groups, so we used prefix di, and the groups are methyl groups. So 2, 3 dimethyl butyl, because it contains 4 carbon atoms. 2 methyl groups are branched to the main carbon atom. So this compound is called propyl chloride. propyl chloride because it contains a chlorine and the first carbon atom. So it's called CS3 CH2 CH2Cl, chloropropane or propyl chloride. When that propyl chloride is treated with alcoholic potassium hydroxide, you know, alcoholic potassium hydroxide is an ionic form, so it contains K positive and OH negative because potassium has higher electropositivity than hydroxyl group, and hydroxyl group or OH group is a electronegative. So what happens is because of this chlorine has electronegativity, so the bonding pair in between carbon and chlorine moved towards chlorine atom. As a result of that, there is a pulling of electron taking place towards chlorine. As a result of that, chlorine might have nice or slight negative charge, and because of moving electron from carbon atom, carbon might have slight positive charge. So that effect happens all the way this bond and this bond. So what happens is this, because of this effect, electron pulling effect, or because of the electronegativity of chlorine atom, the bonding pair slightly moved into chlorine and the chlorine gets slight negative charge. So what happens due to that effect? This bond also gets slightly polarized. That means here carbon gets a slight positive charge. Because of that movement of electrons, this carbon might have slight negative charge. And due to that electronegativity of chlorine atom, this potassium K positive combined with the chlorine result in the formation of potassium chloride. Plus, and the OH combine with the hydrogen atom and forms H2O. And after removing hydrogen and chlorine, each carbon atom have valence is free, and that valence is combined together and forms a bond, additional bond here. So we will be having CS3 CH double bond CH2. So it's a double bond compound. That's why it's called ENE, because contains 1, 2, 3. We use prop, so it's called propene. 1, 2,